Let's try to do a multinomial logistic regression. And we're going to use this study as inspiration for an example of a multinomial logistic regression. So my inspiration comes from a journal article called Understanding Young Adults' Report of Contact with Their Parents in a Digital World, Psychological and Familial Relationship Factors. Of course, you have to remember I just used this as inspiration. The example we're going to do together doesn't necessarily have to replicate the results of a study. It uses a completely different data set and maybe only has a few variables in common. So this was just used as inspiration, but I thought it might be fun for you to see where I got my examples from, and maybe you can go and have a read of this article and be inspired by it. So, on to our study then. You would use a multinomial logistic regression when your outcome variable is categorical, but there's no meaningful order between categories. So an example of this would be race. You can have people of different races, but you can't order it anyhow. Similarly with religion. In this case, we will have the following research question. Do family satisfaction and feelings of obligation towards parents influence the type of technology that students use to contact their parents? So the predictors here are a scale of family satisfaction and another scale representing feelings of obligation towards parents. The outcome variable is the technology used. So with the first category we had phone calls, in the second category we had a video chat, and the third one was text messages. And what you see next is the data command where we have linked the data set to this MPlus input file so that MPlus knows where to take the data from. Then under the variable command we have the first section, names, and this represents all the variables in the dataset in the exact same order as they appear there. So if you have 200 variables in your dataset but only use 4 in your model, you still have to list all 200 of them here in the exact same order as they appear in your data file, because this is how MPlus knows which column of numbers in the dataset refers to which variable. Then you have to tell MPlus which variables you're actually going to use in this model. So you'd say use variables are, and you would have to list the ones here. So the ones that we're going to use in this model are technology, satisfaction with family, and feelings of obligation. So I'm just going to take all 3 of them and copy them here. Then you would have to tell MPlus that the variable technology, tech, is unordered categorical, in other words, nominal. So you would have to say nominal equals, and in this case, tech. Then, in order to run a logistic regression on it, you would have to use the maximum likelihood estimator. This goes in the analysis section, so you would first have to say analysis estimator equals MLR. Then you would have to do the actual model. This goes under the model section. So you would have model, and now you have to specify the regression path. So why don't you take a moment and jot down the model as you see it. You would want to have regression paths from both family satisfaction and feelings of obligation towards tech. So why don't you have a go? I'll wait. Alright, let's do it together then. So you would first say tech on satis. And this is because for a regression path you always have to say outcome regressed onto the predictor. Then you would have to put a second regression path, tech on obligation. You know, there's actually a simpler way to do it. So if you want to take a shortcut, you can do the following. You can say tech on satisfaction and obligation. And with this one sentence, you're done. So you don't actually need both of them. You can just say technology regressed onto satisfaction and obligation. Either or. So either you choose these two or you choose that one. And with this, our model is done. So it's very quick, as you can see. All we have to do now is save the model and press run and check our results. So now we have the output file, which has been opened on top of the input file. And the first thing you see is a repetition of the input instructions. Then you will remember that the next thing you get is a message here to tell you if you had any problems in your input instructions. In this case we didn't, but it's important to always check this section to make sure you didn't have any errors in your input. When you scroll down a bit more, you will see that we only had one group and 637 students participated in the study. We had one dependent variable and two independent variables, and you can see them here. The outcome variable was tech, and you can see it was nominal, so it was unordered categorical. And if you look down here, you will see the estimator used was MLR. It's always quite handy to check all of this to make sure they are what you would expect them to be. If you scroll down a bit more, you get this portion of the output, which is quite interesting. This tells you the proportion of the sample which fell into each category of your outcome variable. Now, the first category was phone call, the second was video chat, and the third one was text messages. So you can see here that 15.4% of the sample, comprising 98 people, used phone calls as their preferred means of communication with their parents. Then 49.6% preferred video calls as their means of communication, and 35%, so 223 people, preferred text messages. Then underneath this section, you have the section for descriptive statistics. And as always, I recommend that you will have looked at this before you even move to M+, because by this point you will want to know quite a few things about your dataset. Nonetheless, this is quite nice to have it here, because then you can quickly look at some things. Scrolling down a bit more, you will notice that in a logistic regression, you get no information about the CFI, TLI, chi-square, and RMSEA. But what you do get are the log likelihood value and these information criteria which you can use to compare across different models. So these two here, the Akaike and the Bayesian information criteria, give you no information about whether this model fits the data, but it can help you decide between two models by telling you whether one is better than the other. Going on to check the results, what you see here are some regression paths. So you see regression paths from satisfaction and obligation, and you see them twice. Once towards Tech 1 and then towards Tech 2. So now the question is, how would you interpret these? Let's take the first coefficient here. You can see it is positive and it is significant. What this means is that the likelihood of using phone calls increases for those people who have higher satisfaction with their family. The likelihood of using phone calls as a means of communicating with parents is also increased when students have heightened feelings of obligation towards their parents. And the reason why these both refer to phone calls is because you have Tech number 1 here, and this refers to the first category, which was phone calls. So now which category do you think this refers to? Well, it refers to the second category, which in our case was a video chat. So once again, these two coefficients are both positive and significant. This means that the likelihood of using a video chat as a preferred means of communication with the parents is increased when satisfaction with the family and feelings of obligation towards parents are heightened. You will notice at this point that you don't have anything for tech number 3, which was text messages. This is because the last category in a nominal variable will always be used as the reference group. So if you wanted to make phone calls the reference group, what you would have to do is recode the data set such that the one with the highest score or the highest number is whatever you want to have as your reference group. This will be the last group and it will become by default the reference group. A nice thing about logistic regression is that it produces odds ratio results. This is because the results that you get here on the on statements are actually log odds. So if you exponentiate them, you can get odds ratios. For example, let's take this number here, 3.598. The way to interpret it would be the following. Those people who have heightened satisfaction with their family are 3.598 times more likely to use a phone call than simply use text messages. So you'd say to use a phone call because this is tech 1 and that was phone calls, as opposed to text messages because that was the reference group. What do you think this second parameter is? Pause the video and have a quick think about how you would interpret all of these other coefficients. When you're ready, just hit play again. Alright, welcome back if you had a go. So this coefficient here would say that those students who have heightened feelings of obligation towards their parents are 5 times more likely to use phone calls than just text messages. And those who have high satisfaction with their family are 9.78 times more likely to use a video call or a video chat as opposed to text messages. So this is your model. As a final thing, I would like to show you exactly how it is that you get these coefficients from these. So on the right-hand side of the screen, I simply opened a scientific calculator that I found online. On the left-hand side of the screen, I have my model. So let's take the first coefficient, 1.28, and see how we can get 3.598 from it. What you have to do is to exponentiate this coefficient. So you would say e to the power 1.280. And you see that number here? All you have to do is press equals, and you'll see that the coefficient you get is 3.5966. This is not quite exactly the same as the coefficient here, because my calculation that I've done here is based on a rounded value, whereas the calculation that MPlus will have done is not based on rounded values. Let's try another one. Let's take this one for example. You would say e to the power 2.281, enter. So now you get 9.786. You can see it's accurate to 2 decimal places. So there you go. This is how you conduct a multinomial logistic regression, and you use it when your outcome variable is unordered categorical. Thanks for watching. In the next videos, I'll show you how to do a logistic regression and a probit regression when you have an ordered categorical variable. I'll see you soon.